So in this, I'm going to talk about building agentic AI workflow from static workflows to the dynamic autonomous orchestration. So let's talk about what is the generative ICF supercharge the three pillars of ML data. Traditional ML megabytes to gigabytes, typically 1 million training examples. Generative AI tetrabytes to petabyte internet scaling training or 50 trillion tokens. Algorithm, traditional ML, thousands to millions of parameters, serial processing, highly task specific. Generative AI, billions to trillions of parameter examples, GPT-4 at 1.8 trillion general emergent capabilities. Compute, traditional ML, serial processing bottlenecks, executable on a localized hardware. Generative AI, massive parallelized training via transformer deployed as a foundation service. Scaling data algorithm and a compute simultaneously birth foundation models capable of generating across tasks without explicit training. Autonomy exists on a continuous spectrum. You have an LLM, which is an agency over output, probabilistic token by token generation, chatbot, conversational memory loops, retains conversational states, workflow, LLM routed through explicitly predefined hard-coded software steps, agents, dynamic control for LLM device, execution path, runtime key architectural design, moving right across the spectrum, traits, deterministic human control for dynamic system flexibility, deep agent, systemic control over file system, OS, and a localized browser interactions, AGI, theoretical pinnacle, undefined boundaries of artificial general intelligence. The foundational agentic loop. An agent is a software entity designed to perceive, decide, and act to achieve a specific goal. Input, user request, plan. LLM decompose the user task into subtasks. It act. System execute a specific tool function or API. The output is the final response result. Observe. System feeds tool outside back into the LLM context. Unlike a standard API call, the LLM acts as a both planner and observer, continuously evaluating its progress until the goal is achieved. Workflow versus agent. The control flow distinction. Static workflow. Ask LLM for list of activities. Function scrap availability. Function check user calendar. Function book and a pay. Predefined hard-coded execution path, highly deterministic and predictable, ideal for mission-critical regulated latency checks. Dynamic agents, calendar access, booking systems, search API, LLM brain, control flow device by the LLM at runtime, highly flexible and open-ended execution, ideal for complex problem solving without known path. The universal autonomy of an agent. The first is like while ecosystem free, for example, LangChain rapidly evolve, these four fundamental primitives remain the bedrock for any using of the brain, the LLM, the core reasoning, task decomposing, and planning engine. The purpose system prompt defines the goal, identity, persona, and behavioral constraint. It is the architectural boundary. The context, the memory, maintains state, combine intrinsic model parameters, active session history, and extremely retrieval data. The action, the hands and eyes, bridging the system to the real world function APIs and internal control. Component, deep dive, brain and a tool, selecting the LLM brain. Task complexity, match model size to problem depth to optimize code. Context window, sufficient token limits to handle conversational memory. Native tool calling model pre-trained to seamlessly output structured JSON or a function code. Latency targets, agentic loops multiply latency. Base model speed is critical. Constraint, data privacy requirements dictating open source was proprietary. LLM, WebSphere, real-time data enterprise DB RAG, code executor, math and logic. Tools give a frozen in-time reasoning engine, the ability to perceive the current state of the world. The architecture of a memory, overcoming the inherent statelessness of foundation model. Without robust context compression, agentic loops will rapidly exhaust token limit, causing catastrophic reasoning failure. Persistent external storage vector database capturing across session user data retrieved dynamically to augment the active prompt. Highly volatile, holds the active within session conversation, requires aggressive summarization to prevent token limit degradation. Lost in the middle, stable and unchanging, consist of the model's learned weights and parameters acquired during the massive initial parallelized training phase. You have an interesting memory, you have a short-term memory context window, you have a long-term memory. The multi-agent architecture, trading single agent simplicity for a specialized delegation, single agent LLM, WebScape, real-time data enterprise DB, code executor, overhead medium, low, less than 2K, general tasks that fit safely inside one context window always starts here. You have a hierarchical supervisor, you have a worker, and supervisor. High requires routing loops, heavy 8K complex task delegation where rigid step-by-step debugging and predictable control flows are required. You have a SOM, you have an agent A, agent B, agency and agent O medium. Token moderate 5K, highly fluid specialized interaction create unpredictable execution path but reduce supervisor bottlenecking. The interoperability challenge, establishing universal standard to replace brittle custom coded interface. The problem, custom Python glue, varying docstring, English language parser, English language standardization, the agent code, the MCP context probe, incubated by Anthropic and Linux Foundation, standardizes connections to data source and external tools. Google emerging standard for agent to agent communication, standardized protocols to agent to user application interfaces, AGUI. Evaluating agentic system, the evolution onion, the LLM core, instruction following, base capability, toxicity, and hallucination rate. Second is the agentic loop. The third is the application. The second is the agentic loop, task decomposition, logic, tool selection, accuracy, and loop efficiency, the application, end-to-end task success, system latency, and cost in UK. Evolution method, code-based evolution. Deterministic, cheap, and highly scalable, the mandatory baseline for the application with a known ground truth output. LLM as a judge, qualitative and scalable, uses a superior foundation model to grade the open-ended outputs of the agentic system. Human evolution and annotators, expensive and slow, but strictly necessary to ensure nuisance tone and safety before full production deployment. Production pitfall and architectural depth. Deploy agent as a junior assistant, not flawless autonomous entity. Infinite loops and error cascade. The freedom to dynamically plan execution path introduces the risk of unrecoverable loops. Early decomposition errors exponentially compound across tool calls. Cost unpredictability. Dynamic loops eliminate static cost modeling. A seemingly simpler user prompt may trigger extensive, recursive, and highly expensive API looping if the agent struggle to resolve the task. Context degradation. Stuffing immense code bases or unchecked tools output into the context window triggers lost in the middle phenomenon, catastrophically degrading the LM reasoning capability. Volatile framework instantly. The ecosystem shifts weekly. A rapid version changes, example LangChain 1.0 architecture breaks, and a sudden model deprecations create immediate unavoidable technical debt. Mitigation protocol, mandate human in the loop approval for the state changing action, implement strict loop caps, and require comprehensive execution tracing. The third paradigm shift in the software engineering, software 1.0. Humans write explicit if-then logic rules to process input, C++, Java, Python syntax. Software 2.0, software 2010, human provides input-output datasets, neural networks learn the dying rule, data cleaning architecture section. Human uses natural language to prompt foundation models that dynamically orchestrate tools to solve open-ended goals, natural language and contextual. Framed adapted from this thing. The readiness builder, weathering the transition, elevating your career from the syntax generation to the system architecture, anchor in fundamental. AI escalates output, but physics, database architecture, network protocols, and a core math remains the bedrock of a resilient system. Understand the basement layer. AI thrives on a localized pattern but fails at holistic end-to-end code-based comprehension and truly novel ideation. Broaden your scope across the entire system. Stop competing as a raw syntax writer. Become the architect who defines the over-charming problem, design the complex solution, and own the final business outcome. Models are stateless artifacts. They cannot build client trust, navigate organizational politics, or forge genuine network connection. The human layer is the ultimate professional mod. Not magic, just architecture. Agents are simple software system combining a stateless reasoning engine with a stateful memory protocols and executable external tools. The technology is incredibly potent but rapidly maturing. Expect frameworks, instability, impact fact reasoning, and a design system that feels gracefully. Treat AI as a powerful junior assistant, aggressively audits its output, own the system design, and prioritize the human connections.